Heating, ventilation, and air conditioning, or as it is known in the trades, HVAC, plays a big part in the comfort and energy consumption of a home. A lot goes into an HVAC system. It's much more than simply running supply ducts to each room. During the next few minutes, we're going to look at two aspects of air distribution systems: duct installation and duct design. We'll point out potential problems and give you some important tips on installing comfort. Proper installation of ductwork is key to conserving energy and increasing comfort in a home. Sealing ductwork is a major part of a proper installation. Duct leakage can cause a number of problems, including pressure imbalances, which can cause air infiltration, reduced indoor air quality, and even backdrafting of combustion appliances. If ductwork is not sealed properly, the air we've spent money to heat or cool never makes it into the living space. It's estimated that in the average house, we lose from 15 to 25% of heating and cooling energy because of leaks in the ductwork. That's 15 to 25 cents for every dollar we spend wasted.
We did a study of 100 new houses not long ago, and the average duct leakage in those new houses was almost a ton of air conditioning that was going into the attic and the crawl space that was just lost.
The conditioned air is not going to where it was intended. It's finding its way into the attic, into the crawl space, in between the floors, things like that, but it's not coming out of the supply register. And that's really what the whole intention is getting the designed amount of air out of each of those grills.
Sealing ductwork properly can drastically reduce duct leakage, in some cases down to near zero. Some subcontractors have been sealing ductwork for years. So why then do so many systems leak?
The simple answer is that ductwork leaks because people put it together with duct tape, and duct tape doesn't work. It works for a lot of things, and it's great stuff, but it doesn't work on ducts.
It'll lose its adhesive properties, it becomes dried out and brittled. It doesn't deal well in high moisture situations such as you may find in a crawl space or even up in an attic in a hot, humid climate.
Building science experts recommend the use of mastic to seal joints in ductwork. Mastic is an adhesive that can be painted onto many surfaces, including metal and flexible ducts. Fiberglass mesh tape should be used in combination with mastic in some cases. This mesh tape can help prevent cracks caused by vibration or expansion and contraction caused by temperature changes. Using the right materials and paying attention to details can pay big comfort dividends. Air leakage is most likely to occur where two components of the ductwork are attached. Let's take a collar, for example. When attaching a collar to a metal box, it's standard practice to join the two pieces by depressing the metal tabs on the bottom of the collar to hold it into place. However, without proper sealing, this can be a major source of air leakage. This contractor first seals the outside of the collar with mastic, careful to cover every possible gap. Then he reaches inside the box and paints mastic over the metal tabs underneath the collar. Notice how he covers the entire surface. This is a good example of how this connection should be sealed. Remember, every joint can be the source of air leaks. When attaching the supply duct to the collar, it's important to properly seal the connection. First, peel back the insulated casing to reveal the plastic flex inner liner. Cover the entire collar area with mastic. Again, careful to paint over any joints. Slip several rings of the flex liner over the collar, making sure there's enough of the duct attached to prevent it from being pulled off later. Secure the flex to the collar by attaching a collar tie, pulling it tight. After you pulled the insulated casing back over the plastic flex and secured it, be sure to seal that joint as well. Remember, anytime you have a joint in the ductwork, you have potential air leakage problems. Boot and grill connections are also major sources of air leaks and energy loss. Most ductwork contractors install the boot to the ceiling or subfloor first, and then attach the supply line to it, often using only duct tape. Unless this connection is reinforced with mastic, it's difficult to permanently seal the connection this way. A different approach can make the process more efficient and easier on you. This contractor makes all of the boot connections before the job leaves his shop. First, he pulls the insulation down to reveal the inner liner and slides the liner over the metal boot. He secures the liner with a pen-to-it strap or collar tie. He then seals this connection with mastic. Pulls the insulation back up over the liner and secures it with a collar tie. Insulating the boot itself is very important. Insulation helps eliminate condensation from developing on the metal surface of the boot, especially in the summer. First, measure the insulation and cut it to fit the entire depth of the boot. This contractor first sprays the boot with an adhesive to keep the insulation in place. He then attaches it to the boot using a UL 181 foil tape. Notice, he leaves a small portion at the top of the boot, which will give him just enough clearance to attach it to the subfloor. When the boot is attached to the subfloor, it is nailed into place using the traditional installation method. However, once it is secured, all the joints in the boot are sealed with mastic. Every nail hole, every small gap, including the gap between the wood and the boot, should be sealed. This same technique should be used when installing boots in ceilings. Air leakage doesn't just happen on the supply side of a system. Sealing return ductwork is equally important. All joints in the return ductwork should be sealed with mastic. Every joint in the metal, every nail hole are all potential pathways for air leakage.
Okay, I'll put this side here on first.
If it's your job to make the plenum connection to the air handler, taking extra care to seal this connection is extremely important. It is here that much of the air leakage can take place. Proper technique starts from the moment the connection is made. You can see these small gaps at the corners can be potential sources of air leaks. This contractor first seals these small gaps with a UL 181 foil tape. He then uses a fiberglass mesh tape around the entire connection. Finally, he paints this surface with mastic. After this connection is sealed, it's important to secure the insulation. This contractor holds the insulation in place with a UL 181 foil tape.
Okay, about right there. Go ahead on up. Squish it in real good there.
He takes the door of the air handler off, both to protect it and to make sure the seal isn't broken by opening this door in the future. As before, he uses fiberglass mesh tape around the entire connection and then seals it with mastic. The techniques for sealing ductwork are the same, whether you are using metal or flex or duct board. Seal every joint along the way. Reinforce with fiberglass mesh tape, and you will reduce air leakage and increase comfort.
If we looked at ductwork the same way we look at our plumbing, we could learn a lot from our friends, the plumbers. Because in plumbing, we wouldn't want to have a plumbing system that was substantially leak-free, nor should we want a duct system that's just substantially leak-free. We want it to be leak-free, period.
Leaky ductwork is certainly among the top reasons for energy loss and comfort complaints in a home. But there are also other reasons. Ductwork that has been constricted, the air pathway, can also cause comfort problems.
When we think about airflow, we should think about water coming out of the hose. And you want to be able to get the maximum pressure out the other end. And the more bends and kinks you put in that hose, the slower the water is going to come out. Whereas if you make that hose nice and straight, the water is going to flow continuously. We're going to have the maximum amount of pressure coming out, and that's really what we're looking for. So we find ductwork looks sometimes like pressure is being squeezed to get through spaces. We have 6 squeezed through a 2x4 area. So we see all these constrictions, and these all create problems.
Dan McFarland is a building science expert with Advanced Energy Corporation. He sees countless examples of air distribution systems choked off because of improper installation.
In this situation, the contractor put his hangers up too high into the joist space. This is creating a constriction in this flex duct, and all along there's a hanger. If he had put the hangers a little bit lower, we wouldn't have had this problem. Whenever we're installing ductwork, whether it be for heating and air conditioning equipment or for an exhaust appliance, we want to keep our ductwork in as straight a line as possible, because we know that each turn in the ductwork can create restriction in the airflow, and restricted airflow has a negative impact on the performance of the equipment. We're in the knee wall area of this home. This knee wall area will be used as a storage closet by the homeowner. The HVAC contractor has done a good job of putting the ductwork as far out of the way as possible. This will maximize the storage. The problem that we have in this installation is that by putting this ductwork behind this bracing, it's created constrictions all the way along the supply run. We designed the system for 8-inch duct, and the constrictions that we have is 6 or 7-inch duct, and that's not what we're designed for. We want to make sure that the system is operating as it was designed and as we intended, so we can maximize the comfort for the homeowner.
A well-designed air distribution system is essential to the comfort of a home. Some HVAC contractors rely on equipment to do the job, and that, according to the experts, is a mistake.
If I don't get my air distribution system right, all the money I spend on a high-efficiency piece of equipment will go for naught, because I'm not getting the comfort at high efficiency, but it's not getting to where I want to go. It's like driving a Porsche and having a finely tuned Porsche, but only having 3 wheels in the car. You know, it wouldn't be a real enjoyable ride.
So the way it looks with a return plenum, and your unit is about 50 inches long.
Jeff Rylick designs residential energy systems. His company handles everything, from insulation to HVAC equipment. Jeff's energy plans include a detailed ductwork design with an emphasis on efficiency.
It's kind of one of those places where you get points for style. A nicely laid out system that's symmetrical, where your turns are nice and smooth, and things like that is going to carry air a lot better and go a long way toward a comfortable air distribution system.
A well-designed, comfortable air distribution system has straight runs and gradual turns. This layout shouldn't change if you are using flexible duct.
The thing about flex duct is that it's flexible, and so that makes it really nice, you know, in that you can avoid the plumber, you can snake it around. And I hear people use that term. I cringe every time I hear somebody say, well, you can just, you know, snake it from here to there. You need to run ductwork like it's already ductwork. That's the way it carries air around. So because flex is flexible, sometimes is a disadvantage instead of an advantage.
Jeff bases his duct design on information he gets from a computer model based on the load calculation standards found in the Air Conditioner Contractors of America, or ACA, Manual J. He factors in the amount of glass in the house, the framing materials used, insulation, flooring, orientation to the sun, and much more.
What we try to do is a room-by-room computer model, giving us heating loads, cooling loads, and airflow calculations for each room. What follows from that is a duct design. And having a design is a useful tool as a framer and plumber, something that allows us to do material lists and everything else.
Determining how much air should be delivered in each room and returned back to the air cooler is an essential part of the equation. As a contractor, you can use a number of tools to design air distribution, including ACA Manuals J and D and computer programs based on the ACA design standards. Without a plan, your air distribution system will not deliver comfort.
If we're just doing this on a random basis, just pulling ducts from a rule of thumb, it's not accounting for the fact that people live in the building and the fact that their lifestyle and their perception of comfort. Duct systems need to be designed to the house as a system.
If I only have, let's say, 1,000 CFM of air I'm going to generate, where do I want to distribute that to? Where are going to be the hottest parts of the house? Where are going to be the coolest parts? Where do I need more air? If I'm on the south side of the house, I'm going to need more air there. Do I need more air in the kitchen, in the bedroom? So I want to design to make sure I am going to have an even temperature distribution throughout the house.
And another one at this end. Let's see how we can match them up on this pair of windows.
The design of the air distribution system can affect more than comfort. It can also impact the health and safety of homeowners.
I can't tell you how many people complain about everybody wanting to go to bed at night and close their doors, and then the room gets hot and stuffy, so they have to leave their door open all night. And not to mention the indoor air quality aspects of that, because if some rooms are going positive, obviously some rooms are going negative. And when that happens, they can carry contaminants with them. You can get backdrafting of equipment and things like that, and it becomes a real health risk.
Undersizing of returns and their improper placement contribute to indoor air quality problems. It doesn't take long to find a potential health risk in new construction.
Underneath stairways is a very common place for HVAC contractors to install returns. It allows us plenty of room for our larger components. In this case, the contractor has done a good job of sealing this return with mastic. The problem with the location in this house is that it's located next to an exterior door. This exterior door leads us out to an attached garage, and the attached garage has created a whole other set of problems for us.
Those problems can include car exhausts, paint fumes, the gases from any chemicals stored in the garage are sucked in through the return. As we wrap up, let's have a quick review. Leaks in the ductwork rob a house of energy and comfort, so it's important to seal every joint in the ductwork with mastic and fiberglass tape. Do not use duct tape to seal ductwork. Constrictions in the ductwork choke off airflow. Straight runs or gradual turns make for better systems. And ductwork should be designed to deliver maximum comfort to homeowners. The work you do as a ductwork installer and designer has always been important. After all, a house is only as comfortable as its HVAC system. Now you can become an even more important part of the building process. You can build comfort for years to come.